Hey guys, Forrest here with ViatoRVR. Nicole and I have been hard at work over the last few weeks on ViatoRVR, and I'm excited to show you where we are now. Shortly after releasing the last video, we were asked to fill a table demo spot for a last-minute cancellation at the US Ignite Application Summit. We decided to take them up on the offer, and on June 1st, began working frantically to get something worth showing off put together. We had 12 days to get it done, and we made full use of this time, working late and occasionally all night. After seeing our progress forward, I think you'll agree that it was time well spent. To briefly recap, last update I demonstrated hand tracking and gaze detection. These are two features that are often at the core of any VR experience, but they only scratched the surface of what we needed to have done in order to show off the project in any meaningful way. Since then, we've prepared the initial versions of a number of other features, including teleport-based locomotion, grabbable objects, pointable objects, and a laser pointer, floating text, user-activated sound clips, and a simple 3D environment built with purchased models and some materials. I'll show a quick demo of each of these at work, and then show a walkthrough of the final scene people got to try in Austin. There are a lot of ways to move around in VR. Even with room-scale virtual reality, like what the HTC Vive offers, you will eventually need a way to move further away than your play space will allow. There are a ton of ways developers are working on to make movement feel more natural and less nausea-inducing, one of which you can see demoed right here. Teleportation-style locomotion is popular right now, and is introduced in the HTC Vive tutorial, so it's familiar with users. So for now, we've settled on this kind of movement. In our implementation, the user holds the thumb pad button down on either of the Vive motion controllers to produce an aimable indicator of where they can move. The parabola shape indicator allows you to aim for areas that are on the other side of objects that are in your path. When the user releases the button, they are transported to the area that they were pointing to, if they were pointing to a transportable area. In the editor, we can manually draw the allowed movement areas to avoid having users teleport through walls or onto objects they shouldn't be able to. The ability to grab and move objects in the scene is one that really lends itself to a user feeling immersed. Shown here is an initial prototype of this behavior. Sadly, this feature did not make it into the demo we showed off in Austin, but it is definitely going to be a part of future demos moving forward. Notice that as a user reaches towards an object they can grab, there's a small light emission that comes from the object. Objects that cannot be grabbed do not make that emission. Another kind of interaction feature we worked on was a simple pointing mechanic. By pulling the trigger that the index finger rests on either controller, the user can point at objects in the scene. Objects that are set up to be pointable can then perform different interactions, such as change color, play a sound, or spawn other objects, like a text block, into the scene. Of all the features I've discussed so far, getting labels for objects that are being interacted with has been one of the most challenging to work on. As of the time of this video, this interaction is still kind of buggy, but I have a number of fixes planned that should make this work a little better. Much of the difficulty came from using an unusually difficult to use billboard framework in Unreal Engine. After a while of struggling getting custom fonts, specifically Unicode fonts for things like Japanese characters working, I decided to utilize the still experimental 3D widget framework built into the engine to show the text. Another difficulty with this text framework stems from determining what rotation and position to spawn the text object. Because the text is 3D in the scene, it can be occluded or blocked by other physical objects. I worked on some small fixes before we gave the demo to try and adjust for this occlusion, but there's still a good amount of work to be done to make sure that the text is always readable to the user, regardless of where they are or where the text is. This feature was surprisingly easy to implement. By utilizing an audio file parameter on the different interactable objects that we place in the scene, it's easy to trigger sounds based on events.
Sphere. Cube. Cube.
We purchased some 3D assets from an individual selling their work on the Unreal Engine marketplace that resembled a Japanese classroom. Since early lessons in many language learning programs involve learning classroom vocabulary, we figured this would be a great small-scale environment to show off as an initial prototype. We took our work on the above features and combined them together to build out an early prototype of our application. In this clip, you can see that I'm able to move around the classroom using the parabolic teleportation locomotion. I can point at objects using the laser pointer, and I can hear audio and see vocabulary as floating text after pointing for a second or two. And this is a little bonus. Despite not being able to show it off in the demo in Austin, I've made a single object in this scene grabbable just so you can see what it looks like. I cannot stress enough how much of a rough draft this is. At the very most, this demo serves as a proof of concept for the baseline of features that we intend to have by the end of this initial 16-week pilot period. There are bugs to work out, improvements to be made, and actual lessons to be constructed. Notably missing are the features that we'll gain by making the application network-enabled, including interactions with other users and instructors. We have plans to add a tutorial to make jumping in and trying it out easier for people who have not exactly experienced virtual reality before. All this hard work didn't go unnoticed. On June 15th in Austin, Texas, our project was awarded with 2 of the 5 awards given out during the application summit, including Best in Show. We're incredibly grateful to the Mozilla Foundation for providing us with the demo space and travel grants needed to have this opportunity. We'd also like to especially thank Lindsay Frost, Katie Mitchell, and Nichelle Mohan for being incredibly helpful and making the whole experience relatively painless. Needless to say, the past few weeks have done nothing but fuel our drive towards building a great language learning experience. Before I go, I also want to give a shout out to local graphic designer Zach Duggar, who worked incredibly hard to get a logo and some initial branding work done in time for our demo. It's rare you find somebody who can do quality work quickly for a reasonable price, but Zach managed to do all 3. If you have a Vive and want to give the demo a try, you can grab the source code from GitHub. I've packaged a release marked version 0.2 Austin Demo that you can grab to try out what we had on display on the show floor. Or you can follow the dev branch for more up-to-date recent updates. Well, that's it for this update. For more information about our project and for any contact info, please check out ViatorVR.com or follow us on Twitter at ViatoR_VR. Be sure to subscribe to our channel here on YouTube if you want to be notified as we add future updates. Thanks for watching and have a great week!